Hello viewers, I am Maitli. Today we are going to see 11 CBSE Maths Limits and Derivatives exercise 13.2 question number 11. In that, find the derivative of the following functions. There are 7 subdivisions. In that, we are going to find the derivative of each of the following functions. Now let's see the first one. In the first one, it is sin x cos x. We can see two different functions. It is in multiply. Sin x into cos x. That means we should not directly do the differentiation of each and everything for multiplication and division. There is a rule, we need to follow the rule. Here it is in multiply means we need to follow the product rule. Product rule means, let me write, let y is equal to the given thing. Product rule already I have told you in the introduction video, but anyway I'll repeat it. Differentiating of dy by dx is equal to, keeping the first one as it is, we are going to differentiate the second one. Second one for cos, it is minus sin x, plus keeping the second one as it is, we are going to differentiate the first one. For sin it becomes, for sin it becomes cos x. Now here it becomes minus sin square x plus cos square x, which is cos square x minus sin square x is nothing but cos 2x. So final answer for the sum is cos 2x. For sin x into cos x, it is cos 2x is your final answer. That's all with the first one. We'll move on to the second one. Here in the second one, they have given secant x. Secant x directly we can't do. There is no differentiation. It's only secant x. For in that case, I am going to change the secant x as writing let y is equal to secant x. We can change the secant x to be 1 by cos x. So I have changed secant x to be 1 by cos x. Now it is in the divide form, so I am going to follow the quotient rule. Here following quotient rule is dy by dx differentiating is equal to first the denominator, then the numerator differentiation. Numerator is a constant term, so it becomes 0 minus numerator into denominator differentiation. Denominator here is cos x, so it becomes minus sin x by the denominator square. So cos square x. Now here it becomes 0. Here minus into minus will become plus. So plus sin x by cos square x. Here we have cos square x in the bottom, so I am going to write this to be sin x by cos x into 1 by cos x. I am splitting the denominator cos square x as cos x into cos x. So here it becomes tan x and here it is secant x. So the differentiation or the derivative of secant x is nothing but tan x into secant x. Now we'll move on to the third one. The third one, it's given as 5 secant x plus 4 cos x. Already we have done the secant x value, so directly substitute it. Let y is equal to the given question secant x plus 4 cos x. Now dy by dx is equal to, for addition we can do it separately. For multiplication and division we need to follow the rule. Now this becomes 5 into tan x secant x plus 4 into, for cos x the derivative is minus sin x. So it becomes 5 tan x secant x minus 4 sin x. This is the final differentiation for question number 3. We'll move on to the fourth one. In the fourth one, it is given as cosecant x. So let me write the cosecant x to be, let y is equal to cosecant x. I am going to take cosecant x as 1 by sin x. So again with the quotient rule, because it is in division, so quotient rule. So dy by dx is nothing but denominator into numerator differentiation. So differentiating of 1 it becomes 0 minus numerator into denominator differentiation, it becomes cos x by the denominator square. So sin square x. Now here it becomes minus cos x by sine square x. The same way I am going to do, I am going to separate the sine square x as sin x into sin x. It becomes minus cot x into cosecant x. So differentiation of cosecant x is nothing but minus cot x into cosecant x. Now we'll move on to the fifth one. The question here is 3 cot x plus 4 cosecant x. Sorry, 5 cosecant x. Now this becomes we are going to do it separately. Let y is equal to 3 cot x plus 5 cosecant x. So we know the value for cot x, it is minus cosecant square x. So 3 into minus cosecant, differentiation of cot x is minus cosecant square x plus 5 into, just now we found it to be minus cot x cosecant x. Now this becomes minus 3 cosecant square x minus 5 cot x cosecant x. You can also take them separately as minus cosecant x outside, 3 cosecant x plus 5 cot x. Both the way you can write it. We'll move on to the sixth one. The question here is 5 sin x minus 6 cos x plus 7. Here differentiating, let y is equal to the given thing 5 sin x minus 6 cos x plus 7. Here it is in addition or subtraction, we can do it separately. So differentiating dy by dx is equal to 5, let it be the 5 itself. Here sin x will become cos x minus 6, cos x will become minus sin x. This is a constant term, only constant term is here, so it becomes 0. So this is equal to 5 cos x plus 6 sin x. So this is your final answer for the sixth sum. We'll move on to the seventh one. In the seventh one, it is given as 2 tan x minus 7 secant x. Here let y is equal to the given thing 2 tan x minus 7 secant x. Now differentiating, it's in addition or subtraction, so easy. 2 into, for tan x we have found the tan x to be secant square x minus 7, already we have found for secant x, it is tan x into secant x. Now this becomes 2 secant square x minus 7 tan x secant x. If you want, you can also take the secant x outside, or otherwise you can leave it as it is. So that's all with the sum. We have found all the differentiation of the given functions. Thank you.